Nemo 3D. Important features, Part 2. 1. Image sequence textures. Quite often you get graphics design created by someone else, in a different software application, and you need to build a project from the elements of this design. Sometimes, this task is easier, or, if it contains animations and effects impossible to create in Nemo, you need to use a sequence of images rendered from another tool. Frankly, this is done more frequently than it should. A sequence of images is given by the original designer and you only need to add the text on top of it. Simple to do, but usually not the best practice to create a project. However, Nemo does a lot of things to support this method, simply because it is needed. First, you have to import and convert the sequentially numbered images into a proprietary file format, and it is this file the application will load and use. Let's create a new page collection file, and name it tutorial3. Choose the Build Image Sequence item from the Tools menu. Here, you can see various options for the sequence file to be created, and also about which files to use from the sequence. The file compression options are uncompressed. This is the fastest to create, but also produces the biggest file. Since a sequence file is loaded into system memory and streamed from there to the GPU, that is, the onboard memory of your VGA card, use it with caution. RLE compressed. RLE means run length encoded, an easy and lossless type of compression. If the images contain a lot of parts that are the same color, for example, black or transparent, this is a useful option to produce smaller files. Lossless compression. This is a similar compression to zip or other well-known file compression techniques. This option may produce the smallest file size, but it is also the slowest to decompress and stream to the GPU. Hardware compression. This is the default and also the best option, unless your images are so big or the animation is so long that it produces a file too big to handle. Decompression takes place in hardware, on the GPU, so this is the most efficient to stream from system memory. But it is also a lossy compression, meaning you do not get the same image after decompressing it again. Most of the time, particularly if you compress graphics, this method will work fine, but if there are a lot of colors or color blends used, there can be noticeable banding due to loss of colors. In these cases, if you find the result unacceptable, try another method. Otherwise, it is best to stick with this default method. The rate of compression is fixed at 4:1. If this results in a huge file, you'll also need to choose another option. There is a very good reason why the compression ratio is fixed. Graphics cards are only very fast if they can work on a lot of pixels simultaneously. If a block of pixels is compressed to the same amount of data, many blocks can be handled at the same time, making this type of compression very efficient. Most of the time, you would want to convert all the sequentially numbered images into a single file. It does not matter if the sequence starts at 0 or 1, but the number has to be incremented by 1. If there is a hole in the sequence, conversion will stop there. You can also specify, if you do not want to convert the whole sequence, at which file to start, and set the number of images to convert, starting from that file. There are also options to create the smallest file possible to conserve memory. If the file sequence is the same size as your video resolution, but the actual animation takes place only on a portion of the screen, you should check the crop to bounding rectangle option. You simply should not compress and stream empty, that is, totally transparent pixels needlessly. With all these efficiency settings, you may still end up with a file that takes up gigabytes in your memory. Even if you have a lot of it in your PC, it is a real drag having to load those gigabytes every time you open the project. If you can get away with it because you do not need the original size, you can also resize the images before they are converted. This is what the rescale value is for. If it is 1, this means the original size, but you can set this lower if a smaller size is good enough. When all the options are set, browse for the images on your disk. They can be anywhere, but, of course, in the same folder. You can also set which of the images to use to create a thumbnail from. This thumbnail will be used in the project to represent the sequence. When everything is set, click on Convert, and wait until the conversion is finished, then click on Done. Let's see how this converted image sequence works. Add a page, then add a primitive object to it. Create a new material for this object, and name it mSequence. Now create a texture for this material on its Texture 1 slot, and choose Image Sequence as its type. Pick the newly created file. Now select the primitive object again and resize it using the texture dimensions. We see the bounding box around the object, but nothing is visible on screen. The animation saved as the image sequence starts with an empty image. But if you click on play, the image sequence will be played back automatically. Now click on the Textures tab and take a look at the properties of this type of texture. There are 3 main options: Play Once, Loop, and Keyframe. Play once is what you have just seen. Loop is the same thing, but it plays back the sequence in an endless loop. The third option provides the most flexibility. You can set keyframes on the frame index property to play back the images of the sequence in the order you want. The first frame always have an index of 0, and your current video settings also influence where on the timeline a keyframe should be set. If your current video mode has 25 frames per second, for example, in Europe, and your sequence is 250 frames long, you need to set a keyframe at exactly 10 seconds on the timeline if you want to play back the sequence in full and at its original speed. Of course, with keyframes, you can slow down or make it faster, but that could decrease the quality of the playback. But you can also easily play a sequence in reverse, or ping-pong back and forth. Or, even more importantly, loop only a portion of the animation. When the design has an animation for the elements in the background for the end part of the animation, then there is a portion that needs to be played back in a loop. You can set keyframes to achieve this by using the loop option. The sequence we just converted and loaded is also such an animation. The first 75 frames is the in part, and the rest, from frame 76 to 225, is played back in an endless loop. To achieve this, set 3 keyframes on frame index. Frame index is 0 at time 0. Frame index is 75 at time 3 seconds. And frame index is 225 at time 9 seconds. Now double-click on the name of the animation, which is frame index, to open the animation curve. You should see a perfectly straight line with 3 dots indicating the 3 keyframes. Now click on the L button to open the loop settings. Here you set the index of the starting and ending key of the loop. The number you set, however, is the index number of the keyframe and not its timing. The first keyframe has an index number of 0, the second is 1, and so on. Since we want to loop between the second and third keyframes, set 1 for the start key and 2 for the end key, then choose infinite for the number of loops. Click on OK when you are done and also choose the Timeline tab to get back to the timeline. A small indicator next to the name of the animation property shows that this animation has a loop defined. There is also another option among the properties for this type of texture that lets you upload the whole sequence to the GPU. This eases the load on the hardware because there is no memory-to-memory transfer needed for every frame from system memory to GPU memory, so playing back a sequence this way makes it almost as efficient as with a still image. Beware though, that this option is not for big sequences because this can eat up the memory on your graphics card very fast. Two. Shape and color blend textures. This is a texture type that is generated by Nemo. Either to create a bitmap with a 2D shape, or a color blend that you can apply on another object, for example a rectangle, or, in case of a color blend, on text. Let's try the latter. Create a page and add a text object to it. Justify the text to the center to keep it on the center of the screen, and make it big by locking the character width and height and changing one of these to 4. Now create a material and name it M Text Blend. Add a texture to its texture 1 slot and choose Shape, Color Blend as its type. A bitmap will be created at its default size, which is 512 by 512. For a color blend, this is more than fine. We can leave the shape at its default setting, which is rectangle. A color blend is automatically created, with 2 distinct colors at its 2 ends. The blend starts with a white and ends in black. You can make the blend more subtle by adding more colors. Just double-click right below the band showing the blend itself to create a new color. You can select any of these colors, edit them, move the position of the colors in the blend or delete a color if it is not needed. To change a color, select it, then click on the square next to the blend. This opens the usual color dialog panel. Here you can pick a color the usual way, and you can also set the transparency. Any color in the blend has its own transparency value, so you can make the texture partially transparent. You can also set the direction of the blend, although for text, it is probably best to keep the default value, that is, vertical. If you want to see how a shape works as a texture, add a rectangle, place it below the text and adjust its size. Create a new material for it and add a shape color blend type texture to it. If you want, you can change the color blend to make it different than the one we already created or make it uniform instead of the blend. Now change the shape to star. You can choose from various shapes, or even draw one yourself if you choose the spline item from the list. The application draws this shape on the texture, then applies this texture on the object the same way it does with a still image. If you rotate the rectangle around, you can see how it looks. If you want to see the back side of the rectangle with the same texture on it, just check the two-sided option.